Hello guys, welcome to my YouTube channel. Today we are going to talk about ADL lookup, argument dependent lookup, and I hope you all enjoy this video and learn at least what is the ADL lookup once and for all. So let's start with an example. I'm going to create a namespace called CS because we all love CS and that's why you are inside this video, right? So we're going to create a namespace CS, and inside that namespace, let's create some classes like class, class algorithm. And just for purpose of this video, this one class is enough. And okay. When we're in CS, it's not all about programming. Sometimes we also need some mathematics. So let's create another namespace as well, like namespace math. And in this namespace, we all know that math has different sections. So let's have the class algebra, for example, and also let's have the class geometry, just for fun. There is no need to have two classes, but just for fun, let's have two classes. But as we know, functions, although functions are inside the math as well, but today we are dealing with C++ functions. So let's define our functions inside the CS namespace. Let's define a function f that I like. So void f. Let's give it a argument. Okay, let's give it a geometry argument from the math namespace. So I need to define the namespace I'm going to use to give access to the namespace of math to be able to define a geometry argument for my function. And let's just say, okay, so cout, cin, endline, all of these are in the standard namespace. So I'm going to say search the standard namespace, cout, then print something like algorithms that are not using geometry. So we technically don't need to use the argument. I'm just printing something to be able to run the algorithm and show you that the function is running. End line. Okay, so then we're going to come here, define our math variable math geometry g, like this, and say, okay, so now let's call the function. So let's call function g with the argument g. Function f with the argument g. Let's actually change the name of this. I don't like it. Let's call it geom. And then change also this to geom and geom. I love it this way more. I could also keep this g, but I want to use g again. So let's just keep it like this. So we defined a geom argument which has type geometry. So geometry is a type of a class that we defined in the namespace of math. And then called the function f inside the namespace of CS, but I haven't written CS dot dot. So let's run it. Oops, the function is not running. But why? Why it is not running? The answer is clear because as it is said, use of undeclared identity f. So what's the issue? Function f is inside the namespace of CS. So we can't just use it and think that everything is fine. But so the C++ will tell us that, okay, you are calling function f, but the function f is in the namespace CS, so I don't know exactly, I don't have access to it. So you need to give me access. I said, sure. So let's call CS. Now let's see what will happen. Algorithms that are not using geometry. Done. Perfect. Did we learn ADL? Well, okay, not quite, because I think that was very obvious. I just made a stupid mistake, and the program was suddenly not working. Okay, let's make another function. So void g. That's why I didn't want to use g there. So for this one, let's give a math argument, algebra, and like alg, and let's give also another argument, which is in the CS, because we need to do something with that algorithm A. And for purpose of this one, let's just say, okay, std cout algorithms that use algebra. For instance, an std end line. Okay, now let's come here and define an algorithm. Okay, let's define an algorithm. CS algorithm, like DP, for example. We all love DP, yes? And let's also define math algebra. What kind of algebra? Of course, linear algebra, our favorite part in the mathematics. So now let's call the function g. This time, I'm not going to make the same mistake that I did last time. So, okay, let's call the CS to give access to our function g. Then let's give it our arguments. And what are the arguments that we're going to give? It's an algebra and an algorithm. So we're going to give it linalg and dp. And then we will try to run the code again. This time I didn't make any mistakes. Right, that seems perfect. Algorithm that use algebra. But now your question is that, wait a second, then what was the purpose of this video? Everything, it seems super obvious here. What was the purpose of it? Well, you know, it's kind of pain that write this CS every time. So what happens if I remove it? Well, your answer will be, well, you have seen what will happen. You will see an error because you already done it with F. Well, okay, but I want to do it. You know, I'm stupid. I want to do it again. Wait, whoa. This time it's working. But wait, what is the difference between these two? And exactly at this moment, I will tell you, hey, this is the purpose of today's video. The reason that this function is working is a rule called ADL. ADL. And what does this ADL stands for? Argument dependent lookup, or it has also another name, which is a Koenig lookup, because it's attributed to Andrew Koenig, but of course it's not invented by him, but it's attributed to him. So what does this rule says? So let's see what is the exact definition of this rule. This rule will tell you that, okay, let's assume that we have a function f. Okay, let's assume that we have this function f. Then this function f, let's assume that it has an argument a, which is in the namespace s. Like, for example, right here, our function f has an argument, which is this jump, which is in the namespace math. Our function g has an argument alg, which is in the namespace math, and it has a argument a, which is in the namespace of CS. Then what will happen is that then C++ not only will search the current scope for the function that matches f, it will also search the namespace s for the function f as well. And this is the reason that it can find the function g. Why? Because it has the argument dp. What is argument dp? Argument dp is an algorithm. It's in the CS namespace. So when we reach here, it will go inside the dp namespace, which is CS, and it will find the function g. But what was the problem with the function f? So function f was working like this, right? And jump is in the namespace of math. So okay, it will search main and it will search math, the namespace of math. But it will never see a function f in them. That's the problem. So what this ADL says is that, okay, so it will serve if you have an argument that is in the same namespace as the function itself, you can remove this part. You can write, of course, CSG, lineage, and DP, but that's too much. You can simply remove it, and everything is fine. Isn't it beautiful? Well, that was the entire purpose of the ADL. But also, I forgot to say something. There is also a secret use of ADL in my code at this point. That I wrote it, but I never mention it. So, let's look at this. std_cout. So, where does we define this operator? Cout is a function. But where is this operator defined? That's also defined inside the standard library. So why didn't we say, okay, let's implicitly define that? And again, I'm using it twice. And in none of them I defined the namespace of that operator. The reason is exactly ADL. Cout is one of the arguments of this operator. So to be clear at this point, like for example, when you have plus, it works like this. So arg1, then the operator plus argument 2. Cout is one of the arguments of this function or operator. There are no difference with each other. And when this cout as an argument is in the namespace of std, then the C++ is smart enough to go and search the namespace std to find the operator. That's the whole purpose. And this was all that I wanted to talk about ADL. Please like the video if you enjoy these types of video. And please make some comments if you would like me to create a video on any specific topic, whether you have a midterm or final for CS246, CS246E in the University of Waterloo, because all the contents of these videos are based on the materials taught in those courses, specifically by Professor Brad Lushman. And that's all. Thank you for watching the video until the end, and I hope you have a wonderful term using C++ and other languages. See you soon.